So this is review 2 of college algebra, page number 9. We skipped review 1 just because it's too elementary for where we're at. So let's start out as integers as exponents. It says on page 9, when a positive integer is used as an exponent, it indicates the number of times a factor appears in a product. So stuff that you're already familiar with, 7 cubed would be 7 times 7 times 7. Where a is the base and n is the exponent, or in this case 7 is the base, 3 is the exponent. When we have 0 or negative integer exponents, whenever we have 0 as an exponent, it always equals 1. And whenever we have a negative as an exponent, it always means that, in fact this would be over 1 if you were to make it a fraction, and that means that this negative right here means that the a and the 2 go in the opposite position there and give us 1 over a squared. So if you look at some of the examples that are on the bottom of page 9, they have things like, I'll do this in red here, 4 to the negative 5, that would be 1 over 4 to the 5th power. All that negative sign means is that we move our number in front of it and our number after it to its opposite position. If we were to have something like 1 over 0.82, and I put that 0.82 to the negative 7th position, that means that it would move to the top, and the 7th power would still be on there. So all that negative means is we change the position of what that negative is on. So for example, if we had this, that would equal y to the 8th over y cubed. So it changes position there is all that does. So that's one of the key things that you're going to be doing here, is when you have things with a negative exponent, that'll be your first step usually, is to get rid of that negative exponent there, and that'll help you out. So let's look at example 3 on page 10. We have x to the negative 3, and then we have y to the negative 8. Okay, let's make that y a little bit better. And we're going to put that over z to the negative 10. So we're going to move our z up, we're going to move our x down, and we're going to move our y down, and we're done there. If you look at the bottom of page 10, there's some properties of exponents. You should already know those. So for example, if we had y to the negative 5 times y cubed, that means that we're going to add our exponents. So we get y to the negative 5 plus 3, which is going to give us y to the negative 2 for our answer, or y over, or 1 over y squared, if we want to make sure we have a positive exponent. So if you keep looking down at those examples that they give there, you'll notice that the letter E there has an example that we want to try here, and E says 45 x to the negative 4 y squared, and we're going to take that to the negative 3 power, and then we're going to take 9z to the negative 8. In fact, let's put, just like their example here, let's put the entire problem in parentheses here. Leave that as a negative 3, but let's do this. Okay, so what we're going to do is we're going to do as much as possible with the numerator and then the denominator, and then if we can cancel, we'll do that. So let's see what we come up with. Okay, so what we're going to do is we're going to do our reducing first. So we're going to reduce this here, and that's all I'm going to do. Okay. And that leaves me with, I'm going to distribute this negative, so that's going to leave me with 5 to the negative 3 x to the 12th, because I'm going to multiply these two, and then y to the negative 6, and then over z, and that'll be positive 24, because negative 8 times negative 3 is positive 24. Okay, so once I do that, let's start moving stuff around so that we have our exponents positive. So we're going to take and leave our x12 on top, and then we're going to take our 5 and move it down, because we can cube 5. We can't take 5 to the negative 3 power. Bring our y down, and our z to the 24 we'll leave there. And the only thing we can do here is change our 5 cubed to 125. And then that ends up being our answer to the problem. And I'm going to assume on page 11 you've done enough scientific notation that we don't have to spend much time on it. But when you have a number like 151,700,000, that's in standard form or general form, decimal notation, lots of different words to use that, and I want you to change it to scientific notation. It's always, always, always the first digit is, or the decimal is always one digit to the right. So there's never a number bigger than 9 here. So from 1 to 9, always. And then we count how many decimal places we had to go from here all the way over to here. So 1, 2, 3, 4, 5, 6, 7, 8. So that's times 10 to the 8th power. And you know, obviously, to go back, you just count that many zeros and move your decimal to the right. And if we have something like 0.000003, again, the 3 goes, and then the decimal, and then we have 10, and this time we went this way, 1, 2, 3, 4, 5, 6, 7, and we put a negative on there to show that what direction we ended up going there. Okay, order of operations, bottom of page 12, should not be much trouble for you. All that is the old time PEMDAS that you've had lots of experience with. And one thing that a lot of people get messed up on is the rules of operation. You do your parentheses first, then your exponents, then your multiplication and division from left to right in the order that they occur. So if I have 6 divided by 3 times 2, you do your division first because it shows up, and then you multiply it by 2. Because if you do it that way, you get 2 times 2 equals 4. If you do your multiplication first, you're going to get 6 divided by 6, which equals 1. Okay, and the way to do it is that right there. Okay, the same is true with your addition and subtraction. If you have 6 plus 3 minus 2 minus 6 plus 4, you're going to start here, 9 minus 2 minus 6 plus 4, and you're going to have 7 minus 6 plus 4, 1 plus 4, and you're going to get 5. And actually, when it comes to addition and subtraction, you can pretty much do it in any order you want, but usually they just go in order from left to right. So again, following order of operations, example 9, part B, you're just going to follow the rules. You're going to do the parentheses first. So let's do our 10 divided by 2 plus 9 times 4, and then you do your exponents, and when you do your exponents you get 32 plus 9. Okay, then we get 5 plus 36 over 41, giving us 41 over 41 equals 1. Okay, key thing here is you do everything on top, everything on bottom is two separate things until the very end, and then you do your division. And that just makes life so much easier. So last thing we're going to cover in here is example 10, which has to do with compound interest. And just from the example 10, we'll take the formula for compound interest. The amount equals principal plus 1 plus the rate over the number of times that it's compounded times the number of times it's compounded times how much time that money is invested. So for this one, they're talking about $1,250 invested at 4.6% interest. So P is $1,250. Our rate is 4.6%. And it's compounded quarterly. So our N, number of times it's compounded, is 4 times. And they want to know how much money is in the account at the end of year 8, so in 8 years. So the amount we have is going to be A equals 1250 times 1 plus 0.046 over 4 to the 4 times 8 power. And if you go ahead and do the math there, you'll find out that you have 1802.26. Okay, so that's just using a calculator, just doing the math. Having an exponent of 32, add these two together to the 32 power, and then multiply that times 1250, and you will get the right answer. So that is it for review section 2.